In a free country, the men and women in the government are dependent upon the people and responsible to them for the use made of the power which has been given them. In any good system of government, there must be ways of controlling and limiting the amount of power anyone has, as the flyball governor controls and limits the output of the steam engine. One of the chief controls over the power of a government is the law of a country. The law is a body of statements about what may be done to or by any person. In free countries, all people are equal under the law, which they are responsible for keeping. To help them to keep it there are police and judges. Our bodies govern themselves in many ways, but we have to control them consciously too. We have to be their judges and police when necessary. But in a well-governed country, there is little work for police and judges. A good education develops the power of people to govern themselves in more and more complex ways. As population increases and as people become more responsible for meeting their needs on a larger and larger scale, machines become more important. As the facts become more complex, machines are being used more and more to do all sorts of measuring, counting, and controlling. Can machines think? In a sense, yes. In another sense, no. They can answer a question if we have built into them the power to answer that sort of question. We can make machines work for us, but machines cannot tell us what that work should be. It is people who are responsible for the direction of the work. A person has to know not only how to do things, but whether to do them and when. A machine has only to do what it is made to do. Free men and women have to make up their own minds about all important questions. How does one learn to do this? By being with, talking to, and watching others who are able to think for themselves. One may see how to think for oneself. One gets better at it by trying. Education in this cannot start too early. How do people come by their ideas about what is better and what is worse? About what things are important in life, what unimportant? How do they judge between things? We have grown to what we are out of the past. We have come a very long way through change and growth from the first living cells. All living things, however simple, control themselves to some degree. Many cannot be said to have ideas, but they have direction. Within limits, they have self-control. Thinking is the most complex sort of self-control, and our brains, with which we think, are the most complex systems of feedback. The thermostat and the flyball governor are about the simplest of them. In feedback systems, effects control their causes. In the thermostat feedback circle, the effect of increased input of fuel is increased output of heat. This effect feeds back through the thermostat and cuts down the input of fuel when the increase becomes too great. In the flyball governor circle, the effect of more steam is more output of work from the engine. This effect feeds back through the governor and cuts down the steam when the engine goes too fast. In the brain, millions of feedback circles are always controlling one another. Our past is a very small part of all time, but it is a very important part. How old are the stars? How old are the sun and the earth and the moon? Nobody knows for certain. It is not possible at present to be certain about such great questions as these, but two things seem probable. The universe is about 5 billion years old. It has been becoming more and more complex from the start. However we try to think of time, it seems certain that the earth is older than our minds can take in. Things have been going on for a longer time than we can think of, and they will go on and on through a longer time in the future than we can think of. 70 years seems a long lifetime if compared with the present minute, but if compared with the age of a stone, it seems no time at all. There is a Chinese poem which says, "Quickly the years fly past forever. Here forever is this spring morning." We have to think of time and space together, here and now, there and then. We cannot see with our eyes how far off in time and space the stars are, but astronomers can measure their distances. Their unit of measure is the light year, the distance light travels through space in a year. The greatest telescopes of today let us look 2 trillion light years out into space. The stars we see there are 2 trillion light years away. We see them as they were 2 trillion years ago. We are looking into the past. Let this curving line represent growth from simple to complex in the world. In this picture, the past is to the left, and we men and women of today are at the top of the curve. Long, long ago, the only sorts of changes that took place were, so scientists say, very simple, in comparison with the changes which are taking place in you now as you read this. The curve represents the change from simple to complex. The higher it goes, the more complex are the sorts of changes which are taking place. In the beginning, as long ago, as far back in the past as we can talk about, the only sorts of changes which took place, scientists say, were physical changes. They were the sorts of changes which the science of physics is about. Here is a wheel turning round. Its motion is a physical change. Here is water boiling, and here is water turning into ice. Here are clouds forming and rain falling. These are physical changes. Much later, other sorts of changes, more complex than these, began to take place. Here is a lighted candle. As it burns, the heat melts the candle, and the liquid goes up into the flame where it is turned into gas. So far, all is physical. But in the flame, chemical changes take place. Carbon from the candle and oxygen from the air come together to make carbon dioxide. At the same time, water is given off, as you may see if you hold a glass cover over the flame. The cover quickly becomes clouded with little drops of water. This water was not in the wax, and the candle flame gives it off however dry the air is. The water and carbon dioxide come into being through the chemical exchanges between the lighted candle and the air, which make the flame. At the same time, there are physical changes taking place. The top of the candle is melting, and the liquid fuel is moving up into the flame and being turned into gas. Air is coming into the flame. Carbon dioxide and water are moving up from it, and heat and light are being given out.